In this example, we're going to be working with the implicit equation in parentheses x minus 3 raised to the second power plus y squared over 4 is equal to 1. Now this equation is an equation of an ellipse, and we have the graph of this ellipse given here too. So what we're going to do here first is we're going to solve this equation. It's an implicit equation because the x's and the y's are all mixed together in this equation. And we're going to solve this implicit equation and actually get two different explicit functions, y in terms of x. So what we're really doing is just taking this equation given and isolating our variable y. So as we're looking at this equation, we see that y shows up only in one term. It's the second term on the left-hand side of the equation. So what we're going to do is first isolate that term. So we'll keep the y squared over 4 on the left side of the equation, but we're going to bring the term that has x in it, the x minus 3 quantity squared, over to the other side of the equation by subtraction. So now we've made progress. There's only one term that has y in it. It's by itself. And so now we're going to just work our way to get y by itself. So the next step would be to multiply both sides of the equation by 4. That would leave us with y squared on the left-hand side. And we'd have 4 times, and we'd need parentheses for everything, or parentheses around everything that was already there on the right-hand side. The next step here to get y by itself would be to undo the perfect square. So to undo the square, we would need to square root both sides. But see, that square that's on the y is really hiding the information about the sign of what's in it. And so when we square root both sides of an equation to solve, what we have to do is we have to remember to have a plus or minus part that goes along with it, because that plus or minus is indicating that what was inside the square could have been positive or negative. So we have the plus or minus square root, and we keep everything else there on the right hand side underneath the square root. Now what we do have here, we can simplify just a bit, because we have the square root of the product of two things. The square root of 4 times a bunch of stuff in parentheses. Now 4 is a perfect square, so we can actually pull that 4 outside of the square root by taking its square root. So we can pull that out as a 2, leaving us with just the 1 minus parentheses x minus 3 quantity squared underneath the square root. Now it's tempting to try to go farther, but because of that subtraction sign after the 1, we don't have any sort of what's given under the square root is a difference of things, not just the product of things. We could pull the 4 out because it was 4 times something. 4 was a factor, and so we could pull the factor out using properties of exponents. But now, because we have subtraction underneath there, unless we were somehow able to factor what's underneath and have a repeated factor, we can't pull anything else out from under the square root. So this is what we're left with. So really what we have here is two explicit functions. One that's covering the top half of the ellipse that we have pictured. That would be the one that comes with the plus sign. And the one that comes with a minus sign is actually the part that's covering the bottom half of that ellipse. And so it makes sense that both the top half and the bottom half independently would be functions themselves. They would pass the vertical line test. But when you put it all together, the ellipse itself is not a function, but in some sense it's made up of two branches, each of which is a function. And so those would be our two functions, explicit functions, that are in some sense hidden inside this implicit equation.